Alright guys, today we got a Brood Marine Company 17 SEER heat pump. This thing is pretty awesome. This system is 4 years old, and we're testing it. We got a service call out here, and the thermostat just wasn't set right. She got confused on thermostat, so had it set on heat instead of cool. So it's currently 82 degrees in there with about 75% humidity, so this thing's working pretty hard. And since we get a lot of questions about the test of time, how they work, 4 years old, this total system amp draw, 3.5 amps. That's it. That's compressor, fan, all of it. This is why these inverter systems are the future, and amazing, and worth every single penny. Very, very nice. And to only be operating at 4 amps of power right now at 70% capacity full bore here, it's running really well. Very efficient still. Even after 4 years, it hasn't really lost any of its efficiency at all. So, like locked rotor amps, you know, when the compressor starts up, it's 35. It's a startup amp draw. You know, max is 16, which it normally runs, as you can see, about 3 amps to 6 amps. Whereas you come over here and look at this unit here, this Goodman unit, it's locked rotor amps. Somewhere around here, 58. So it's almost double the actual amp draws. And this system is 6 years old. So side by side, 2 units, you can see the savings between an inverter versus a standard AC. That thing pretty much runs double the amp draw. So amps times volts equals watts. For every 1,000 watts you use, that equals a kilowatt, billable at whatever your electric company bills at. You know, down here in these parts in the summertime, it's 11 cents a kilowatt. So you can easily see how double the number equals a lot more power consumption. So it costs a lot more. So we're gonna wrap this thing up and let her run. And just a quick little thing about today, about inverter systems and how they run even years later. So, thank you for watching.